Hi everyone, we did a problem like this, similar to this in the previous video. So I'm just going to show this really quickly. Here we have a 0.92% sodium chloride solution, and so it tells us that we're using our formula of the weight volume. Okay, and so we're given the percentage, and we want to know the W, the grams of NaCl in a 250 milliliter solution. So this is what we're given, that's what we're looking for. All right, we know, so there's really two ways we can do this. So I'll go ahead and show step 2 and 3 here. We know that if we have a percentage, that means that it's always out of 100. Okay, and so based on that, you have 0.92% was what you were given in the problem. That means you have 0.92 grams per 100 milliliters because that's what a percentage is. It's always out of 100. And then you can just take your 250 and multiply it times your conversion factor. So milliliters cancel, and you're left with 2.3 grams of sodium chloride. All right, and so the way I look at it also is that I know that 0.92% is out of 100, so I go ahead, I write out my formula. I know that it was weight volume because that was given in the problem, and I just go ahead and account for that 100 because that's a percentage. So I just go ahead and move my decimal place 2 places over because that's what I did here. When you divide by 100, you move the decimal place over twice, right? And so then I see that I'm looking for grams, and I have 250 milliliters. So in order to isolate grams by itself, I multiply 250 times 0.0092, and I get 2.3. So either way, you take that percentage and you can plug it in this way or look at it that way. Parts per million is used when you have a solution that has a very, very small concentration. So just like we have looked at scientific notations, we use those because we have really large numbers or really small numbers, and it just looks a lot nicer that way. So parts per million isn't really a new unit. I mean, it is, but it's just basically instead of multiplying times 100 like we've been doing for a percentage, you multiply times a million because it's called parts per million. So it's set up the same way. So you can use parts per million for mass or for volume. So you take that part over whole times a million instead of 100. If you have two liquids, you take volume of solute, your part, over the total volume of solution. That's your whole times a million. So it's the same thing. So notice that my units here are grams and here are milliliters. Okay, and so it's just mass of solute over total mass of solution or total volume, and use volumes here. Key being this. Okay, so this is a problem very similar to your homework. So we want to look at the concentration in parts per million of DDT in plankton. All right. Excuse me. You notice you have grams over grams. So we have a little issue here, right? We have milligrams and we have grams. So we need to plug in, there's our grams times a million. This needs to be converted to grams. It can't be in milligrams. So remember, if we convert to grams, we move our decimal, you divide by 1,000. So if you need to do that, write it out and divide, that's fine. But you end up dividing by 1,000 because there's 1,000 milligrams in a gram. So we move our decimal over 3 places. So we get 0.00040, or that would be 4.0 times 10 to the negative 5th, okay, in scientific notation. Okay, check that real quick. Okay, and then we can't forget that. So when you divide these two, okay, you're going to get 3.63 times 10 to the negative 8. But then, instead of multiplying times 100, because then you would still end up with a really small number, right? Okay, so instead of multiplying times 100, multiply times a million. So we get 3.63 times 10 to the negative 8, and then we multiply that times 10 to the 6th, and we get 0.036 parts per million. Okay, so we just take grams over grams times a million, and that gives us parts per million. And we could do this for volume. We could do milliliters over milliliters times 10 to the 6th. All right, I hope this helps.